that is it clear for you that the entropy is extensive function or not? And by the first calculations, we will find a type of the entropy which is not extensive, and that caused a problem which we name it that as the Gibbs paradox. But anyway, before to talk about the Gibbs paradox, I want to write just a step. You need to find the omega. Generally speaking, if you fix it, if you have the if you have fixed the energy of the system, the total energy, so the number of the accessible state will be a function which it will get the maximum at the sum value of the energy. This is the average energy. So average energy is defined as a value of the energy of the system that the number of the accessible states get maximum. So
it's every time that the maximum will be in the average energy?
Yes. Number of the accessible state should be maximum at the average of the E. If you have a more than one fixed parameter, E and V, I want to tell you that also the omega will reach the maximum that at the sum point of the average of the N, E, and N. So I mean the partial derivative of the omega or the N and omega and partial derivative of the that in some value of the N, which is called the average of the N, and that's the same also. So the average value, that will be the 0. Maximum accessible state guarantee for you the existence of the equilibrium in your system. To have the equilibrium, you need to, all the states should be occupied by the maximum number of the particles which is possible. Okay, as I told you, I want to do for the free particle and find the omega for the free particle. So we consider a non-interactive bosonic gas, non-interactive bosonic gas. By non-interactive, we call it this ideal gas because there is no internal interactions between the particles. So for non-interactive bosonic gas, N is the number of the particle the question is about counting the number of the possibility. If you have so omega is given as the number of the possibility. I want to tell you one possibility. If you have just one particle and the V is the volume of the system, I forget, and E is the total energy of the system. Total energy. course, when you have a box and you have just one particle, this is the volume of the box, and you have a one particle, you can consider a tiny volume for the particle, but normally this is ignorable in comparison to the total volume. Anyway, so just let me to write this approximation that you should not consider the volume or the size for the particle. If you want to consider this calculation will be corrected, and you can do that, you can correct, but you need to exactly know that how much of the total volume will be subtracted from that. So I mean that you need to estimate this V prime. So I don't want to do that. I want to start from the easy case. So if you have one particle just, and if the volume of the system is V, so the number of the possibility will be proportional to the volume. Or you agree that if the size of the system increasing, so the number of the possibility also increasing.
Yes.
It looks like that, as I told you, it looks like that the hall with the 500 seats. So when you have a 500 seat and you just want to ask the 10 people to sit there, so with large number of the possibility, the system will be quickly reach the equilibrium position. So if you increase the size of the system, the number of the possibility will be increasing. So hopefully you will reach very soon or quickly to the maximum of this curve. So for one particle that. If you have a two particle, so each particle can occupy the V, so that will be V2. I wanted to tell you that if you have an n particle, the number of the possibility will be proportional to the Vn. This is a very easy calculation. I didn't enter quantum mechanics or something. I will do that in a few minutes. So omega as a function of E and V will be C E and N V over N. And this is some constant. This is some constant. Just by this simple equation, I want to give you very interesting equation. Just by this easy estimation, and using the thermodynamic, P over T is from the S, from the V. And you know that S is K, L, and omega, so just look at K, L, N, C, V, N. This is from thermodynamics. P is T, partial derivative of S with respect to V. Maybe I wrote this before in the last lecture, or no. If no, this is a equation from thermodynamics. You can find it there. Anyway. So just use this expression, this estimation actually, and replace it that here. So, and look at that. This constant, this proportionality constant, is independent from the V, so doesn't have any contribution.